Are you recording? Oh, oops. Okay. So can everybody see my screen? Yeah. Okay. So tonight, we'll do a little review of inheritance because that I think would be helpful, and that kind of leads into composition as a method for linking classes together in Python. And the way that works will be more clear. But so when you talk about inheritance, what example did who went over it? Did Jordan go over inheritance yesterday? What did he use as his examples for inherited classes?
We did employees and then had the programmer and
Okay.
engineering.
So
Or
like
no, accounting.
like a programmer is an employee, or a manager is an employee. So that's how I want you all to think about inheritance. So when you have a parent and a child class, so if the child class is the parent class, but they're more and they're different. So if you think about in terms of mammals, or animals, sorry, a mammal is an animal. A dog is a mammal. A reptile is an animal. A snake is a reptile, and a reptile is a snake. Those are all parent-child relationships. But you can see how it kind of gets like if you kind of think of the taxonomy of what is what in the animal world, it can get pretty complicated pretty quick. But when you think of inheritance, think of an is a relationship. So a dog is always a mammal. So let's take a look. Where am I? No. I'm going to make a composition directory and cd into that directory. So when you use the and, it basically says, execute this command and then this next command. So you could put multiple commands. It comes in handy when you're doing any kind of, like when you get into scripting, like with your shell in Bash or ZHS or whatever it happens to be. So composition. So we're going to be doing this in Python. Let's see if this works. Okay. So let's bring it over here. No, that is not what I wanted to do. I want a new window. Okay. I'm just going. We'll do it with click ops. No. Okay, so before we delve into inheritance, did y'all take a look at how to tell what the parent class for a class is if it's not in the code? So let's say I have a class, my class, and we'll just say it's passed. So we just have an instance of that. Does that class inherit from anything? It does. So all classes in Python inherit from a base class called object. So if I want to know like what the base class is of this. I don't want to debug console, thank you. Okay, so if I execute this, it's going to tell me that it's derived from a class object. So every class and this is just extra knowledge, so you kind of understand. Like Python is written so that every class that doesn't have a parent inherits from this class object. And why do we think that is? Like, can you write a class without like the init method, the constructor? You can, because it inherits an init method from the class object. So if I want to know like what all of the methods are in a class, I can do this dir and then the name of the class. And what do y'all think? You think this is going to have any, you think it's going to have any methods? I mean, this is our class right here. This is what we defined. And the answer is yes, it is going to have some methods because as we looked at down here, it inherits from this class object. So if we run our code again, you can see it's got all these built-in methods, which some of them you're familiar with, like string. Did you all look at the dunder string method for how to return a string for a class, like what the default string is, and then the init, otherwise known as a constructor, and there's a bunch of other ones that we don't look at as much. But those are the two big ones. But you can say like built into every class is a lot of functionality because it inherits from that object class that we looked at before. So I want to basically build a parent-child relationship. So, and I'm going to do that with the concept of a sandwich. So what is a sandwich in the simplest possible terms?
Two pieces of bread with some stuff in the middle.
Okay. Yes. So is a hot dog a sandwich?
By that definition that I provided, then it appears to be that way.
So is a taco a sandwich?
I mean, that's mostly one piece of not really bread, but you know,
Okay.
bread like.
True. So
No,
is it
a hot dog is one piece of bread. Come on here, unless you
Oh,
butcher
okay.
it,
You're
right?
okay?
Yeah.
So is a quesadilla a sandwich?
Yes.
Yes, because it's, I mean, two tortillas, which are,
Yeah.
you know, unleavened. Well, I guess they do have some yeast in tortillas. Two pieces of bread with a filling in between them. But I want to build, you know, a class sandwich. So I have a class sandwich. It's not going to have a parent class. I'm going to define a init method, and I want it to take itself, and I want it to take bread and a filling. And I just want to set self.bread equals bread and self.filling equals filling. And then I want some string method that says I want to return an F string that says I am a sandwich on bread with filling, right? Does that make sense? So I made a class sandwich and now I want to make an instance of a sandwich. So I'll say I want PB&J equals, so I'll make a sandwich. And bread, we'll say white, and then we'll say peanut butter and jelly for the filling. And then I want to print PB&J. Right, so this is, let's give this. What do I do? Oh, I forgot
Yes.
self. I
Okay.
forgot self. Very important, because otherwise, so that mistake kind of highlights why including the self keyword is important. So the self is telling it, look in this instance of the class for whatever bread is defined at. And the filling is telling it, or the self.filling is saying, look in whatever instance of this class for what the filling is defined at. When I leave the self off, it's looking in this function for a variable called bread, and it doesn't find it because there's no variable called bread. But if you put the self on there, it says, hey, whatever sandwich I created with this constructor, look for the bread that I created that sandwich with and look for the filling. And if you leave that off, then it's only looking inside whatever the function is. So that's why I got this error. Name bread is not defined. So it gets to the first error, says what's bread? I have no idea what bread is. It's not in the scope of this string function, and it throws an error. It doesn't even get to the filling, or it would have thrown the same error too. So it quits on the first error that it can't resolve. So if we run it now, it should print. Yep,
I had a
and we
quick
see.
question about that, if you don't mind.
Yeah, go ahead.
So when we're calling the self, say that we were working with like a big file and we wanted to have a class that defined all our variables. Are we able to modify the self to like pull in bread and filling from another class that defines those things? Or does it always have to be self if your function's within that class?
No, so we'll look at this a little bit later when we get to composition, but let's say like, yeah, we'll look at this in more detail at the end. Like I'll cover it a lot. Can we put a pin in the question until that? The answer to your
For
question
sure,
is
thank you.
yes, kind of, but you're not going to use the self keyword.
Thanks.
But the answer is definitely yes. So that's a sandwich. So I can make a peanut butter and jelly sandwich that way, or I can define a class, peanut butter and jelly, and say that its parent is sandwich. And then I just want to define it. And I'm just going to give, so how do I give a default value in a method? Let's say I want to, so that's how you would pass in a list of parameters. So if I want to just hard code what bread is, if it's not passed, I could just say equals whatever I want it to equal. And then the same thing for filling, I can say equals peanut butter and jelly. And then I can just pass those to the superclass, in this case, which is sandwich. And I can say bread and filling. So, okay, so now I have this peanut butter and jelly class, which inherits from sandwich. So I should be able to new PB&J, even though I got rid of it. I should be able to say peanut butter and jelly. I should be able to pass nothing because I've defined these two here. And if I print that, I should get the same thing that we got right here. Why is that? So because in my peanut butter and jelly sandwich class, which inherits from sandwich, I haven't defined a string method, but there is a string method in the parent class. So it's just going to use the string. It should just use the string method from the parent class. So I should just get the same thing I got when I created a sandwich of the sandwich class and not of its child peanut butter and jelly. So let's take a look. Yep, and you see I am a sandwich on white with peanut butter and jelly, even though we didn't tell it to say that inside the peanut butter and jelly class. So basically what's happening here, this super is telling it to call a function directly from the parent class, and it's calling the init from the parent class with this bread and this filling. Okay, so I know we said that hot dogs are not sandwiches, but just for the sake of demonstration, I hope it doesn't hurt anyone's feelings. We're gonna call a hot dog a sandwich just for the sake of demonstrating inheritance. So we'll start with the generic sausage on a roll. And yes, we did agree that you had to have 2 pieces of bread to be a sandwich. So we'll say we just want to say our bread equals a roll and our filling equals sausage. And then we want to say, just want to copy that. So we just want to initialize our superclass, and then let's go ahead and say we want the thunder string method to return a different statement. And we'll say return f string, I am a delicious on it. And I need to put the self there. And say we want a new sausage. We'll say we want sausage on a roll, and then we want to print. So this should print, I am a delicious self.filling, so I'm a delicious sausage on a self.bread, which is roll. What did I do? I have done something wrong. Previous.
You need self in the parameters
Where?
of the init function.
Shouldn't. Because they're defined in the variables are defined in the context of the function.
Does it have anything to do with that string function?
It might. So string self print new sausage roll is sausage roll. Line 27. What did I do? This right.
I kind of copied your code and it's working for me. So
Huh. So what did I do? Did I cause infinite recursion? Something in my string method that it doesn't like.
VS Code tried to auto correct me to a super string function.
We shouldn't need to do that though. We should be able to override the string method. Let's see what happens if it goes. This is gonna work, so. Nope. It's something with my init. Because it gives it.
Do you need a self on line 23?
I shouldn't. Because these are the function variables. Oh yeah, it's to start the function? Yeah, that's what it is. Thank you. That should fix it. Yeah. Yep, so that's it. I forgot the self in the init method. Should be the default first argument of any class methods. So now I have a sausage on a roll. If I wanted to make it a hot dog, I could say new hot dog equals sausage on a roll, and I want the filling to equal hot dog. And then if I print, oh, it should just be hot dog. Type. When I print hot dog, what's going to happen? So I'm not specifying the bread. So does everyone understand what I'm doing here when I say filling equals hot dog? So I'm explicitly telling it, hey, I'm passing in one argument and I want it to be the filling argument. So the bread should be the default value that's specified here, and the filling should be sausage. So this should print out, I am a delicious hot dog on a roll, theoretically. If I leave the filling off and I do it like this, what do y'all think will happen?
It'll assign it to bread.
Yep, it'll assign it to bread. So I'll say I'm a delicious sausage on a hot dog, I think. Yep, I'm a delicious sausage on a hot dog. So if you have default arguments and you want to, or you want to specify what your arguments are, you can just say the argument to the function filling equals hot dog. Another way to do this, instead of declaring a hot dog as a sausage on a roll, is I can just define a new class, hot dog, and it will inherit from sausage on a roll. And we'll just say the inits. So we don't need the bread, we just need the filling. And then we'll say super. Filling equals. So this theoretically should do the same thing as this, although now it's its own class instance. So if I do another hot dog equals, and then I print that, print. It should print the correct, I am a delicious hot dog on a roll. So let's clear out of this. Okay, so does everyone see what's happening here? So we have class hot dog, which inherits from class sausage on a roll. So it takes in a filling, which we've given a default parameter. It calls the super class, which is sausage on a roll, which has bread equals roll as default parameter. We override this filling equals sausage because it will only fill in this sausage if no value is specified when the function is called, but we do specify a value here. So it overrides this with hot dog. So it calls, again, it calls the superclass with the bread, the roll, and the hot dog, and they get set to roll and hot dog. And then because we didn't specify a string method, it uses the parent class's string method. So if we wanted to see what class hot dog and what class sausage on a roll inherit from, we should get that hot dog inherits from class sausage on a roll. Class sausage on a roll has a parent class of sandwich. No, I used the wrong method, didn't I? That's what functions are available. One of the bases. That's yep. So we see hot dog inherits from sausage on a roll, and sandwich inherits from, or sorry, sausage on a roll inherits from sandwich. So we could also have, you know, an adult hot dog. So we'll say class bratwurst, which also inherits from sausage on a roll. Let's all of that. Let's just say so let's take a look at what that looks like. We should get, the expected. So our filling is bratwurst. We inherit from sausage on a roll. So bread is specified as roll. I am a delicious bratwurst on a roll. However, and who was talking about, was that Matt or was asking about referencing other classes, methods and members and parameters earlier? So does it make sense that, couldn't we just make this easier if we had like a class filling and we passed in what the filling was to sausage on a roll, and that was an object. And then we didn't have to do all these other subclasses. We could just create a filling and pass in a filling instead of all these different child classes. Like, how many different ways are there of making sausage on a roll? Do we really need children for all of them when we could just have one parent class that takes in a filling object? I mean, we take in a string here, but what if we want the filling to do some other things, hypothetically, right? So you could have characteristics of the filling, like is it hot or cold? If you're talking about like a hot dog stand monitoring system, like what's the temperature of the filling, something that'll dynamically change. So you need methods to update the temperature from, a thermometer or something. Like, fillings can have a lot going on. So hard coding them as a string might not be the best way to do that. So let's take a look at what that would look like. So this leads us into composition. So composition is different from inheritance. So y'all remember how I said inheritance? I want you to think of an is a relationship, like a mammal is an animal, a dog is a mammal. So I want you to think of composition of a I could talk, I promise. A has a relationship. So a sandwich has a filling and it has a bread. So filling and bread can be classes of their own that are related to sandwiches. So let's just start with what a simple filling class would look like. So we just want a variable for what the type of the filling is to start. So now we have a really basic filling class. I mean, we could do some other stuff, but right now we just specify the type of the filling. So, is it peanut butter? Is it jelly? Is it, a hot dog? Is it pastrami and sauerkraut and Thousand Island dressing for a Reuben? So we can also create a class bread. So now we can specify, rye bread, white bread, wheat bread. We can specify a roll. Hypothetically, if a hot dog was a sandwich, which I think we came to the conclusion that it was not, but if it was, and the power in this is the ability to, I guess the technical way to say it is loosely couple objects. So when we have a parent-child relationship, we have a tightly coupled object. And kind of what I want you to think about that is, so if we have a class sandwich, and so we have bread and filling, but let's say we want to add some parameters to class sandwich. Let's say self dot temperature equals temp. And now we would need to go in and like, we'll say, sorry, like this would be like your serving temperature or something. Like what's the ideal serving temperature? It's like hot, cold, room temperature, whatever. But then, you know, for all of these child classes, like we'd need to go back in and update them now with the temperature. So the more child classes you have, the more work that is. But let's say like our serving temperature is based on our filling. So if we specify our serving temperature in class filling, now when we create a sandwich object, or we'll just, yeah, so we'll get rid of these for a sec. So we'll say we have a new class sandwich. And we'll say we want to we'll call it bread obj because it's a bread object, and it'll be a bread object in this case, just to make it clear. Filling object equals filling. And then say we want a string method. Then we want to return I am a sandwich on bread with. So in order for this to work, we need to define some string methods for these so that string works and knows what to say. So we'll just say return self.type. And then we'll just reuse this for our bread class. And this needs to be bread, self.bread object. And filling object. Okay, so now we can create, what kind of sandwich should we make? We will say a Reuben, so I'll say this equals bread. I want my bread to be rye. And I want my sandwich filling equals filling, and I want it to be, what is it? Pastrami, sour. I'm gonna misspell sauerkraut. There's an E in there, isn't there? That looks close, is that right? So now what I've done is I've created a filling object, a bread object, and now I want to turn those into a sandwich. So I'll just say my Reuben, because Reubens are delicious, equals sandwich. And then I want to pass it in sand bread and sand filling. And then I want to print my Reuben. Okay. So does everyone see what's going on here? So I create a bread object with the type of rye. I create a filling object with a type of pastrami, sauerkraut, and Thousand Island. And then I take those two objects, my bread object called sand bread and my sand filling object, and I pass them to the constructor for the sandwich class. So now the sandwich class has a bread object which is equivalent to this one here. And the filling object in my new sandwich instance has a filling that's equivalent to this object here. And because I defined string methods for these, theoretically, when I print this, it should replace this self.bread object with with the return type of this string here. And it should replace this self.filling object with this return type here from the filling class. So it should print, I am a sandwich on rye with pastrami, sauerkraut, and Thousand Island. And I say theoretically because live coding doesn't always go smoothly. So it worked. So that's what we got. But does it make sense that I have this filling object? Like, why am I passing three things into a filling object? Isn't each of those a filling on its own? So how would I change this so that I can, add fillings to my sandwich, I guess, one at a time.
You could make it a list.
Yep, I can make it a list. So we'll say this self.filling object, we want to call it self.filling object.list equals a typecasted, I think, is a list. Yeah. Do it this way. We'll just make it a list explicitly. So now we take in the filling, and now we need a way to add fillings. So we'll just say find add filling, takes in self, and takes in a filling. Then I'll say self dot filling object list dot append filling. But then our string method doesn't work. So how are we going to print a list of all of the fillings?
The join method?
Yeah, that would work. Although how would we'd have to leave off the and, but yeah, we could join the list and separate them with use a comma and a space as our separator. That's probably the best.
We use list comprehension.
You could use list comprehension. Do you want to walk me through how you would do that? Or just talk me through it?
I guess it would be something like for I in, or yeah, something like print I in I don't know, maybe better if you sorry.
Yeah, so let's just who said use a join method?
I did.
I can't. Is that you, Elijah, or was someone else?
Oh, Kasib.
Oh, Kasib, sorry. The Zoom interface is not my friend. You'd think that, like, as a professional programmer, I would be more technologically savvy, but I am not, and I am not afraid to admit it. So how would I use the join method?
So if we wanted to put like a comma in a space, we would have to type that out as a string, and then it would be like a string of a comma and a space dot join, and then self dot filling object list.
Like that?
Yes.
Okay, I like it. And then we'll just replace this self.filling object with fillings. And then, so we're going to turn this into individual fillings. change this to be then by Ruben add filling, and we want to pass it. And then we want to pass it dressing. Okay, so now what should happen when we print my Reuben? So we've broken all of our long string of 3 different fillings into 3 different filling objects. So now we have pastrami, sauerkraut, and Thousand Island fillings. When we initialize this, we pass the pastrami filling in, and then we add a filling of sauerkraut and add a filling of dressing, which in this case is Thousand Island, and then we print it. It should print what? Well, let's take a look then. We need to explicitly break out the types. Yeah, so this is a group of objects that is a list of filling objects. So let's just do this for filling, filling. So that's not, the reason that didn't work, and we could make it work, but just for simplicity is because it was a list of filling objects, not a list of values. So it didn't know what to do with them. So we could just iterate over a for loop and say fillings.
I think you have to do plus equal, not plus plus, right?
Yeah, I think you're right. Going back to my C++ space. Yeah, that is true state. So it should work. Yeah. But we also want to add a comma in space. So the downside, and I have to use self. I'm doing it to myself this evening. Self-induced errors. Come on, there was a semi-clever pun in there. That one I didn't even like look up. I just came up with that one on my own. Yep, so that method worked. Just to be clear, the join method would have worked also with some finagling, but just for the sake of expediency, I did it this way. And we could tweak it a little so it didn't print the comma for the last object, but basically you have to go through and extract the value that you want from each filling. I mean, I think we could just call the string method and it would return a string also, but this is one way to do it. There are other ways to do it. The last thing I want to talk about with composition is, so we can explicitly set, like we can call a constructor here in this. Let's say, I don't care what bread you tell me I want. I always want this to be rye bread. So now my bread object is always going to be an instance of class bread with a type value inside of rye. So you can compose an object or compose a class with other classes either by passing in an object or calling the constructor inside the object that you want to use. And this will give us access to the members of the bread function, just like passing in an already created bread object would. So quick refresher, just remember inheritance is a, composition is has a. So we looked at, sandwiches with breads and fillings, but you could also think of like a car. So a car has an engine, it has a stereo, it has tires, it has all of these components, but a tire is not a car, but a car has tires. So composition has a relationship. Inheritance is a relationship. What questions do you have about the review of inheritance or composition?
I had a question about the way you use default values in your inheritance example.
Yeah.
You had a class hot dog that inherited sausage on a roll,
Mm-hmm.
and then that init had a default value. You defined the default value, and then the super init. That's really my question is. You had to set filling to filling because you have two. I guess
Because I didn't pass in a bread. So let's say I wanted to just say bread equals roll, or bread equals hot dog roll, just to be more clear. And then I could, so this has more to do
okay, I
with
see.
positional arguments than default values. So if I didn't say that filling equals filling when I called super, and I took off this bread, right? And if I just passed in filling. So the way that the Python interpreter is going to work is that it's going to go look at this sausage on a roll. It's going to say, yep, self. The first argument I have that I can put anywhere is this filling argument. If I don't specify where you want it, I'm just going to stick it in the first value, and then everything else is going to get the default. But if I tell it explicitly that I want my filling, that I want my filling to equal the filling that was passed into this function, then what I've done is I've created I think named argument is the best word for it. So I've told it explicitly,
Name.
hey, when you call this function of the parent class, I want my filling parameter to be this filling parameter that I told you to fill in instead of bread, because otherwise it'll work left to right if you don't name the parameter. But if I tell it I want it in the filling, then it'll pass it in as this argument. Does that answer your question?
Yes, it does. Thank you.
What other questions do you all have? Okay.